You know, if I asked you right now, what time is it, you would probably look at your watch. And if I asked you what time is, you might say, well, it's what my watch measures. But here's the funny thing. The equations that describe everything in physics, from atoms to galaxies, they don't know what time your watch says. In fact, they don't seem to care about time flowing at all. The future and the past, as far as the mathematics is concerned, look almost identical. So what is actually happening when you feel time passing? That's what we're going to figure out. By the end of this talk, you will understand why physicists keep saying time is an illusion, what they actually mean by that, and what is really going on underneath the illusion. And I think you'll find the truth is stranger and more beautiful than any clock could tell you. Let me start with something ordinary. You wake up in the morning, you remember yesterday, you plan for tomorrow. You feel like you're moving through time, from past to future, like a boat going down a river. This seems so obvious that nobody questions it. The past is gone, the future hasn't happened yet, and you're stuck in this little sliver called now. But let me show you why this common sense picture has a problem. And it starts with a simple question. What does now mean? You might say now is this moment right here. But what about right now on the moon? Is it the same now? Well, the moon is about 1¼ light seconds away. If something is happening on the moon right now, you won't see it for another 1¼ seconds. So which now do we mean? The moment it happens there, or the moment you see it here? You might think this is just a problem of communication delays, of light taking time to travel. But Einstein showed us something much more disturbing. It turns out that now is not just hard to communicate. It's actually different for different people. Here's what I mean. Suppose you're standing on a train platform, and a train zooms past you at tremendous speed. Lightning strikes the front and the back of the train at the same instant, as far as you can tell. You're standing right in the middle, you see both flashes at the same time, and you say, those two events were simultaneous. But there's a passenger sitting in the middle of the train. Now, because the train is moving toward one flash and away from the other, she sees the front flash first and the back flash second. And here's the strange part. She is not wrong. According to her measurements, with her clocks and her rulers, the front really was struck first. So who's right? You, standing on the platform, saying they were simultaneous? Or her, on the train, saying they weren't? Einstein's answer is, you're both right. Simultaneity depends on your state of motion. There is no absolute now that everyone shares. Now wait. Let me make sure you understand how weird this is. If two people disagree about whether two events happened at the same time, they might also disagree about which event happened first. If you're moving fast enough relative to me, an event that I say is in my future might be in your past. Your now slices through the universe differently than my now does. So what does this mean for time? Well, think about it this way. Imagine all of history, past, present, and future, laid out like a loaf of bread. Each slice of bread is a moment in time, and the whole loaf is everything that ever happens. Now, in Newton's world, everybody would slice the bread the same way. There'd be one universal now that everybody agrees on. But Einstein showed us that different observers slice the bread at different angles. Your slice might be tilted compared to mine. And if we're moving differently, your present moment cuts through different events than my present moment does. This suggests something remarkable. If there's no universal now, if different observers carve up time differently, then maybe the whole loaf already exists. Maybe past, present, and future are all equally real, and we just experience different slices of it. Physicists call this the block universe. Now, let me give you two different ways to think about this, because it's such an important idea. First, think of a movie reel. Remember those? All the frames are already there on the film, from the opening scene to the end credits. The whole story exists at once on that strip of celluloid. But when you run it through a projector, you experience the frames one after another. You feel the story unfolding in time. But the film itself? It's just sitting there, complete. In the block universe picture, the universe is like the film. Everything that ever happens, the dinosaurs, your breakfast this morning, whatever you'll do next year, it's all there, all at once. We're not watching the universe unfold. We're embedded in it, experiencing our local slice. Here's another way to think about it. Take a map of the United States. Los Angeles exists, New York exists, Chicago exists. They all exist together on the map. You don't say Los Angeles existed in the past because it's to the left of New York. They're just at different positions. In the block universe, 1920 and 2020 are like Los Angeles and New York. They're at different positions in the time direction, but they both exist. The year 1920 didn't disappear. It's just somewhere else in the block, just as real as your present moment. Now, let me explain this as if I were talking to a bright 12-year-old who's skeptical, because that's always the best test of whether you really understand something. Look, kid, you know how when you look at the stars, you're seeing light that left them years ago? The sun you see is 8 minutes old. Some stars you see are already dead, but their light is still traveling to you. So you're always looking at the past when you look at the sky. Well, Einstein figured out that there's no special moment called now that's the same for everyone. If I'm moving really fast compared to you, we'll disagree about what's happening right now somewhere far away. Not because we're confused, but because right now far away doesn't mean anything definite. And if there's no universal now, then maybe all moments are equally real, like all the frames in a movie already exist on the film. We just experience them one at a time because of how we're built. So what about the feeling that time flows? Where does that come from? Here's where it gets really interesting. If you write down the equations that describe how particles move, how light travels, how gravity works, almost all of them have a strange property. They work the same way, forward and backward in time. Take Newton's laws. If I show you a movie of two billiard balls colliding, and then I run the movie backward, the backward version obeys Newton's laws just as well as the forward version. There's nothing in the mathematics that tells you which way is forward. Same with Maxwell's equations for light. Same with Einstein's equations. Same with quantum mechanics. The fundamental laws don't have a built-in arrow pointing from past to future. So here's the mystery. If the basic laws work equally well in both directions, why does time seem to have a direction? Why do eggs break but never unbreak? Why do you remember yesterday but not tomorrow? Why does everything seem to go from order to chaos? The answer, as best as we understand it, has to do with something called entropy. Now, entropy is a slippery concept, but let me try to make it concrete. Suppose I have a box of gas molecules. If all the molecules start out bunched up in one corner of the box, that's a very orderly, low entropy state. But if I wait, the molecules will spread out until they fill the whole box evenly. That's the high entropy state. Now, why does the gas spread out instead of bunching up? It's not that spreading out is required by the laws of physics. In fact, a movie of the gas spreading out, if you ran it backward, would show the gas bunching up, and that backward movie would obey the laws of physics too. The reason is much simpler. There are vastly more ways for the molecules to be spread out than to be bunched up. If you shuffle a deck of cards randomly, you could get any arrangement at all. Most arrangements look random. Very few arrangements are special, like all the suits in order. So if you keep shuffling, you'll almost certainly go from order to disorder, just because disorder is more common. Entropy is a measure of how many microscopic arrangements give you the same macroscopic state. High entropy means there are lots of ways to arrange the pieces. Low entropy means there are only a few ways. And here's the key point. The universe started in an extraordinarily low entropy state. The Big Bang was incredibly hot, yes, but it was also incredibly uniform and orderly in a gravitational sense. And ever since then, entropy has been increasing, things have been spreading out, mixing up, falling apart, This is the arrow of time, not a fundamental law, but a consequence of where we started. We're living in a universe that began with unusually low entropy, and we're sliding downhill toward higher entropy. That's why eggs break and don't unbreak. That's why you remember the past and not the future. Your memories are physical records, and making a record always increases entropy. So the direction of time isn't built into the laws. It's a statistical fact about our universe's history. But now you might be thinking, okay, entropy explains why time has a direction, but it doesn't explain why time seems to flow. Why do I feel like I'm moving through time? Why does the present feel so vivid and immediate, while the past feels like a memory and the future feels like a possibility? Well, here's where we have to be very careful. Because the feeling of time flowing might not correspond to anything in physics at all. It might be entirely a feature of how our brains work. Think about it. Your brain takes in information. It forms memories. It makes predictions. And all of that processing takes physical time, in the sense that certain things have to happen before certain other things. Your perception of the present moment is actually a reconstruction by your brain cobbled together from signals that arrive at different times. When you think you're experiencing now, you're actually experiencing a processed summary of events that happened a tenth of a second ago or so. Your brain even rearranges the timing of events to make them seem coherent. If a flash of light and a click happen at nearly the same time, your brain might adjust them to seem simultaneous, even if they weren't quite. So the flow of time might be a kind of user interface, a way your brain represents changes and sequences so you can act in the world. It might not be telling you anything about the fundamental nature of reality. Now, some people find this disturbing. They say, wait, are you telling me the flow of time is an illusion? That doesn't feel right. And I want to be clear about something. Calling something an illusion doesn't mean it's not real, in some sense. Rainbows are illusions in a way. The colors you see aren't really out there in the sky. They're created by your eyes and brain responding to light of different wavelengths. But rainbows are still real phenomena that we can study and explain. The flow of time is like that. The feeling is real. The experience is real. It's just that the thing we're experiencing might not be what we think it is. We feel like we're moving through a pre-existing future. But what might actually be happening is that our brains are continuously updating their models of the world, laying down memories, making predictions, and calling that whole process the passage of time. Now, let me tell you about a common misconception that trips people up. People often think, well, the past is gone and the future hasn't happened yet. It can't be real. Only the present is real. But think about what that means. If only the present is real, then the present must be some universal moment that exists everywhere in the universe at once. But we already saw that Einstein's relativity rules that out. Different observers slice up space-time differently. There is no universal present moment. So you're stuck with a choice. Either you say, okay, then what's real depends on who's asking, which seems strange, or you say, maybe all moments are equally real, and we just perceive them differently. The second option is the block universe view, and it's the one most physicists find more coherent. Now, this doesn't mean you're fated to do whatever you're going to do in some helpless way. That's another misconception. Even in a block universe, you still make choices. Those choices still matter. They're just part of the block. The you that makes decisions is as real as any other part of the universe. You're not watching yourself from outside. You're living it from the inside. Let me take you through a thought experiment that might help clarify things. Imagine you're a detective investigating a crime. You gather evidence. You piece together what happened. And eventually you figure out the sequence of events. First the victim arrived, then the criminal entered, then the crime occurred. Now, here's my question. When you finally understand what happened, where does time enter your reasoning? You're using logic and evidence to establish a sequence. You're figuring out what caused what. But are you actually experiencing time flowing, or are you just establishing relationships between events? The detective doesn't need time to flow to solve the crime. The detective just needs to figure out which events influenced which other events. The detective needs causation, not flow. And maybe that's what the universe is really like. Not a river flowing from past to future, but a web of events where some events influence other events. We call the influencing events earlier, and the influenced events later. We call the whole pattern history. But the flow part, the sense of moving through it, that might be our contribution. That might be what it feels like from the inside to be a memory-forming, prediction-making creature embedded in the pattern. Now, let me say something briefly about the mathematics, because it's so striking that I think you should know about it, even if we don't go deep into the equations. When physicists try to combine quantum mechanics with Einstein's theory of gravity, they run into a famous problem. The usual quantum mechanical equation, the Schrödinger equation, has time in it explicitly. It tells you how a quantum state changes from one moment to the next. But when you try to write down a similar equation for the whole universe, including gravity, something strange happens. The equation that emerges, called the Wheeler-DeWitt equation, has no time in it at all. The time variable simply vanishes. What does this mean? Well, one interpretation is that at the most fundamental level, the universe doesn't evolve in time. The universe just is. It's timeless. The appearance of time emerges somehow from the relationships between different parts of the universe, kind of like how temperature emerges from the motion of molecules, even though individual molecules don't have a temperature. This is still a contested area. Physicists argue about what the Wheeler-DeWitt equation really means. But the fact that our best attempts to describe the ultimate nature of reality keep bumping into timelessness, that should tell you something. Time, as we experience it, might not be fundamental. It might be emergent, arising from something deeper. So, what is actually happening? Let me try to sum it up. The universe isn't a story unfolding in time. It's more like a four-dimensional sculpture, a block of space-time where all events, past, present, and future, exist together. Different observers carve it up differently. There's no universal now. Within this block, there are patterns. Some configurations influence other configurations. We call the influencing configurations causes and the influenced ones effects. We call the direction from cause to effect the direction of time. This direction isn't built into the fundamental laws. It emerges because the universe started in a special low entropy state. Entropy increases, memories get made, things fall apart. This gives time its arrow. And the feeling of time flowing, that's what it's like to be a creature who forms memories and anticipates futures. It's what it's like to be embedded in the block, experiencing it from the inside. The flow is real as an experience, but it might not correspond to anything fundamental in physics. Now, why does this matter? Why should you care that physicists think time is strange? I think it matters because it changes how we see ourselves and our place in the universe. If you think of time as a river carrying you from birth to death, then the past seems lost and the future seems uncertain. Life can feel precarious, like you're clinging to a moving boat. But if the block universe is true, then in some sense, your whole life is already there. Your childhood isn't gone, it's just at a different location in the block. Your future isn't unwritten. It exists. You just haven't experienced it yet from your current position. Now, this doesn't tell you what your future is. You still don't know. And it doesn't make your choices any less meaningful. You still have to live through it, but it might change the texture of how you think about existence. You're not a fragile creature being swept along by a river. You're a pattern in the fabric of space-time, as real and as permanent as any other part of the pattern. Einstein himself seemed to take comfort in this view. When his oldest friend Michel Besso died, Einstein wrote to Besso's family saying, "Now he has departed from this strange world a little ahead of me." That signifies nothing. For those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. That's a remarkable thing to say. Einstein wasn't denying grief or pretending that death doesn't matter to us who are left behind, but he was pointing to something larger. The person is still there, in the block, at an earlier location. In the deepest physical sense, nothing is lost. Now look, I don't want to oversell this. There's still a lot we don't understand. We don't have a complete theory of quantum gravity. We don't fully understand how the appearance of time emerges from timeless equations. We don't know why the universe started with low entropy. These are open questions, but I think the direction of the evidence is clear. Time is not what it seems. The flow, the passage, the sense of moving from one moment to the next, this is something we do, not something the universe does. The universe is. We experience. And maybe that's okay. Maybe that's wonderful, actually, because it means we're not just passive observers of a pre-recorded movie. We're participants in a pattern so grand that it includes all of history. Our experience of time, our memories, our anticipations, our sense of being alive right now, that's all part of the pattern too. The universe doesn't need time to be real, but we need the experience of time to be the kind of creatures we are. And that experience, whatever its ultimate nature, is something precious. So the next time you feel time flowing, take a moment to appreciate the mystery. What you're feeling is the intersection of physics and consciousness, the place where the timeless block meets a memory-making brain. And that intersection, that little flicker of awareness, might be the most remarkable thing in all of space-time. All right, I've thrown a lot at you. And now I want to hear from you. Here's my question. If past, present, and future all exist equally in the block universe, does that change how you think about regret or hope? Tell me in the comments. I'm genuinely curious what you think.